Hi, in this lecture we generate the parametric equations of a curve that happens to be the intersection between two surfaces. The two intersecting surfaces are two mathematical cylinders. One is x squared plus y squared equals 1, and the other is x squared plus z squared equals 4. These surfaces are what we refer to as mathematical cylinders not just because their graphs are actual cylinders, but because one variable is missing from each equation. From the first equation, z is missing. And from the second equation, y is missing. For the first equation where z is missing, to get an idea of what the shape of the surface would be, we sketch the graph of x squared plus y squared equals 1 on the xy plane. Everyone should know that the graph of x squared plus y squared equals 1 on the xy plane is the unit circle. Then we use this curve to propagate the surface. How we do that exactly is by taking this curve x squared plus y squared equals 1 on the xy plane and propagating it along the z direction. We obtain this series of curves, which we can think of as the frame of the surface. And so we obtain an actual cylinder. For the second surface, the y variable is missing. We sketch the graph of x squared plus z squared equals 4 on the xz plane, and we obtain another circle. This time the radius is 2 on the xz plane. Because the variable y is missing from this equation, we take the curve x squared plus z squared equals 4 on the xz plane and propagate it along the y direction. We obtain a similar series of curves that form the frame of the second cylinder. There are two curves of intersection, one at the top and one at the bottom that we see better when we rotate the tubes. Here we have the two curves without the two tubes. They do look like a couple of bicycle tires that got run over. There are different ways for obtaining the parametrizations. We approach the problem by using a standard parametrization for the unit circle on the xy plane. We set x to be equal to cosine t and y equals sine t. Then we plug in x equals cosine t into the second equation so that cosine squared t plus z squared equals 4. Solving for z, we get z equals plus or minus the square root of 4 minus cosine squared t. Therefore, a parametrization for the curve that is above the xy plane is given by x equals cosine t, y equals sine t, and z equals the square root of 4 minus cosine squared t. For the bottom, we simply have z equals minus the square root of 4 minus cosine squared t.